Welcome to WorldWire. Please subscribe and hit the bell icon for more breaking updates. Rare earth elements are the unsung heroes of our technological age, quietly powering the devices and technologies we rely on every day, yet rarely making headlines or entering public conversation. There are 17 of these remarkable metals, including neodymium and dysprosium, which are essential for everything from the tiny speakers in our smartphones to the massive turbines that generate clean wind energy. Without them, many of the innovations we take for granted simply wouldn't exist. Despite their misleading name, rare earths aren't actually scarce in the Earth's crust. What makes them rare is the difficulty and expense of extracting and refining them. The process is not only technically complex, but also comes with significant environmental and health risks, often leaving behind toxic waste and pollution. These elements are absolutely vital in the production of advanced electronics, high-performance magnets, and the chips that drive our digital world. They're also crucial for the transition to green energy, making them a true cornerstone of modern industry and sustainable technology. For decades, Western nations chose to outsource the environmentally hazardous and labor-intensive work of processing rare earths, largely to China. This decision created a dangerous dependency on a single dominant supplier, giving China enormous influence over the global supply chain. Today, this reliance has turned rare earths into powerful tools of geopolitical leverage. Any disruption in supply, whether due to trade disputes, political tensions, or logistical challenges, can threaten entire industries and economies worldwide. The process of transforming raw ore into usable metals produces hazardous waste and pollution, a burden many countries were happy to avoid in the past. But, as the world's appetite for technology grows, so does the pressure to confront these environmental costs head-on. As global demand for rare earths explodes, the world faces a reckoning with the vulnerabilities of a concentrated supply chain and the urgent need to find more sustainable, secure solutions for the future. Enter Nexperia, a Dutch chipmaker specializing in foundational semiconductors, crucial for cars and countless devices, though not the flashiest tech. Owned by China's Wingtech, Nexperia became a flashpoint for Western fears of Beijing's influence over critical industries. In 2025, the Dutch government intervened, blocking decisions that could threaten Europe's industrial value chain, signaling a new era of economic security. The US had already targeted Wingtech, citing risks of technology transfer and intellectual property theft. Most of Nexperia's chips are sent to China for final processing, giving Beijing a chokehold over Europe's supply. The Dutch move was a desperate bid to regain control, but it triggered a much larger confrontation with China. The stage was set for a global showdown over the future of technology. China's response was swift, halting Nexperia chip deliveries to Europe and freezing key semiconductor supplies. This weaponization of supply chains sent shockwaves through global industries, exposing just how fragile and interconnected the system had become. European car makers, already strained by pandemic disruptions, suddenly faced production stoppages as essential chips vanished. The crisis extended beyond finished products, affecting raw materials and compounding the chaos. Boardrooms and governments scrambled, realizing how much of Europe's output depended on decisions made in Beijing. China's move was a masterclass in economic statecraft, turning supply chains into geopolitical battlegrounds. The world watched as cooperation gave way to conflict in the race for technological supremacy. The supply blockade hit Europe's industrial heartland hard, with the automotive sector the first casualty. Production lines stalled, prices for rare earths like dysprosium and terbium soared, and manufacturers faced mounting financial pressure. The crisis didn't stop at cars. It threatened Europe's AI ambitions, as advanced hardware relies on the same rare earths now under Chinese control. The EU's billion-euro AI strategy suddenly looked vulnerable, built on a shaky foundation of scarce materials. The shortage rippled through the entire tech ecosystem, from semiconductors to electric motors. European industries were squeezed from all sides. No chips, no raw materials, and no easy solutions. Systemic panic set in, forcing a painful reevaluation of Europe's industrial strategy. The message was clear. Technological progress depends on secure, resilient supply chains. In crisis mode, the EU launched urgent diplomatic talks with China, but progress was slow and supplies remained choked. The Critical Raw Materials Act set ambitious targets for domestic sourcing, processing, and recycling, aiming to reduce reliance on any single country. But building new mines and refineries is a long, costly process, and Europe is racing to rebuild lost expertise. Temporary relief came from a fragile US-China truce, allowing some shipments to resume, but the underlying vulnerability remained. The EU's long-term goals are vital, but they offer little comfort in the face of immediate shortages. Europe is learning the hard way that industrial independence can't be rebuilt overnight. The scramble for rare earths has become a defining challenge for the continent's future. China's dominance over rare earths is no accident. It controls over 60% of mining, making it the undisputed leader in this critical sector. The scale of its operations is staggering, with vast mines stretching across the country and a workforce dedicated to extracting these valuable minerals. Even more impressive, China commands a staggering 85% of global refining capacity, transforming raw ore into the high-purity materials needed for advanced technologies. This gives China a chokehold on the supply chain, as few other countries possess the expertise or infrastructure to compete. The real power lies in processing, a complex and highly polluting step that the West was happy to outsource for decades. Environmental concerns and high costs pushed Western nations to abandon their own facilities, leaving China to fill the gap and perfect its techniques. Now, the EU and US face immense hurdles in breaking free from this dependency, as they scramble to rebuild lost expertise and invest in cleaner, more efficient processing technologies. Even when new mines open outside China, they still often rely on Chinese refineries to process their ore, reinforcing China's grip on the market and making true independence a distant goal. For critical elements like dysprosium, which are essential for powerful magnets in electric vehicles and wind turbines, China's monopoly could take a decade or more to challenge. Building new supply chains, developing alternative sources, and overcoming technical barriers is a slow and costly process. This is part of a broader strategy. China's government has made rare earths a national priority, investing heavily in research, development, and global partnerships to secure its lead. China also leads in other key materials for semiconductors and batteries, further cementing its role at the center of the world's most important industries. The world has traded one form of resource dependency, oil, for another, as rare earths become the new lifeblood of modern economies. Rare earths are now at the heart of the digital and green revolutions, powering everything from smartphones to renewable energy technologies. This new reality is reshaping global power politics, forcing nations to rethink their strategies and alliances in a world where access to rare earths can determine economic and technological leadership. The Nexperia crisis is a wake-up call, revealing how efficient global supply chains can become dangerous vulnerabilities. What once seemed like a triumph of modern logistics, goods flowing seamlessly across borders, factories running around the clock, now exposes the fragility at the heart of our interconnected world. The shockwaves from a single disruption can ripple across continents, affecting industries and communities far beyond the original source. Reliance on a single supplier for rare earths is a critical point of failure, threatening jobs, economic growth, and technological progress. When one link in the chain breaks, entire sectors can grind to a halt, putting livelihoods and innovation at risk. The stakes are higher than ever, as advanced technologies and green industries depend on these vital materials. The crisis means higher prices and shortages for consumers, and a direct threat to the green transition. Everyday people feel the impact at the checkout counter, as essential products become scarce or unaffordable. The dream of a cleaner, more sustainable future is jeopardized when supply chains falter. Geopolitical tensions now impact everyday life, from car prices to the availability of electronics. What once seemed distant and abstract, trade wars, diplomatic disputes, now hits home, shaping the choices families make and the technology they rely on. Nations must now prioritize resilience over efficiency, investing in friendshoring, onshoring, and diversified supply chains. Building robust networks is no longer optional. It's a necessity for economic security and national stability. Governments and businesses alike are rethinking their strategies, seeking new partnerships and local solutions. The era of assuming essential goods will always be available from the cheapest source is over. Delays, shortages, and sudden shutdowns have become stark reminders that efficiency without resilience is a risk we can no longer afford. The choices made today will shape the global economy for decades. Leaders must weigh short-term costs against long-term security, knowing that their decisions will echo through generations. The world stands at a crossroads. build resilient networks, or risk a fractured, volatile future. The path we choose now will determine not just economic prosperity, but the stability and well-being of societies everywhere.